Hi, my name is Aneta and this is Chemistry at a Glance. I also welcome you to my blog, Chemistry at a Glance, which all the links I will leave in the description box below. In today's video, we're going to practice some questions on absorption and emission spectrum. If you're not familiar with the topic, please visit my blog and I explain everything there. Before we continue, I also want you to know that everything I posted in my blogs is the way I learned. It was the easiest way for me to learn, so now I want to share it with you guys. And here is our first question. If a beam of light of a single frequency was shown in a sample and it did not correspond to the energy gap between an energy level, what would happen? So basically nothing would happen. For the electron to jump to the higher energy levels, it has to have enough energy. It has to have a packet of energy of the right size for the electron to jump. So if there is not enough energy, it won't just jump a little bit and then stay there. It has to have just enough energy to jump to high energy levels. So our answer is nothing will happen. Nothing, they can't move unless a right packet of energy is provided. So our next question, the diagram below shows the emission spectrum of the hydrogen atom in visible region. Explain why hydrogen emits only certain definite frequencies of visible light. So when an electron drops through our energy levels, O goes up, it has just enough energy to do that. So when it goes up, it needs that exact amount of energy to move. When it's emitted in an emission spectrum, the electrons drop back down. Therefore, they emit energy. And according to our equation, E equals hf, if they have that certain amount of energy, and Planck's constant is a constant, so it's always going to be the same, they have to have that certain amount of frequency as well. So at certain energy, we're going to have a certain frequency which is related to that energy. Therefore, only certain definite frequencies of visible light will be emitted. Our next part. Label the horizontal lines and draw the transition corresponding to the 4 spectral lines in A. Clearly represent the transition of the red spectral line. So the first thing we're going to do is label the lines. The first is always number 1, and then the number goes up. And our last one is an infinity. Now it tells us to draw the transitions corresponding to the 4 spectral lines in A. So our spectral lines in A are right there. We've also got to find is that for hydrogen atom, the electrons drop to a certain series, Paschen, Balmer, or Lyman. In this question it says hydrogen atom in the visible region, and in the visible region we have Balmer. If you're not sure what I'm talking about, please visit the blog and I explain everything in there. It's very clear. But if you know what I mean, it's the Balmer series, and we know it's N equals 2. So the electrons drop to energy level 2. We've got to label the red spectral line, and the red spectral line has the smallest frequency out of these, because the frequency increases this way. And because we know E equals hf, that means it's going to have the smallest energy, because it's directly proportional to E. F is directly proportional to E. Therefore, if frequency is small, the energy will be small. So this drop will be due to the red spectral line. Then we've got a higher one. And another one. And another one. We've got 1, 2, 3, 4 lines. And that's how it should look. Now the next bit says, draw and label the transition corresponding to the ionization of the atom. For the ionization to happen, electron has to be completely removed from the atom. And we know that at convergence limit, the one with the infinity sign, the atom completely loses control over the electron. So ionization will be when the electron goes all the way up to the convergence limit. Okay, next bit. The first line in the visible atomic emission spectrum for hydrogen has a wavelength of 656 nanometers, while that for helium has 707 nanometers. State, given a reason, which line has the higher frequency. So the relation between frequency and wavelength is C F lambda. So they are directly proportional. This means that if frequency increases, wavelength has to increase as well, and the other way around. So if we have 656 nanometers for hydrogen and 707 nanometers for helium, and I knew there's something wrong. Sorry, I think I just confused all of you. If you heard that, just erase that from your memory. That's the equation. So to find frequency, you've got C over lambda. And because C is a constant, it's always going to be the same, so we can write it as that. And frequency is indirectly proportional to wavelength. I knew there was something wrong with me that saying. Okay, so we know that the higher number at the bottom means the smaller the frequency. So the smaller number we have at the bottom, the bigger the frequency will be. So 656 is the smaller number, and that's hydrogen. So hydrogen will have the higher frequency. And now the higher energy, and we've got E equals HF. What you're going to do is rearrange. We know that frequency is C over wavelength, so we can put that in there. Energy equals HC over wavelength. We're doing this because we have the wavelength, but we don't have the frequency in the question. So now I'm just rearranging so that we're working just with the energy and with the wavelength. And as in the previous question, H and C are both constants, so we can write it as this. And it's also indirectly proportional. This means that we again need the smaller number for this to be the biggest. So 656 nanometers is the smaller number, and this is again hydrogen. Okay, now this is a calculation question, so prepare your calculator. Oh, also, if you want to print off these questions and do them along with me, please email me or leave a comment or message or anything with your email address, and I will send you a Microsoft Word document and you will have the questions with you. So, a line in the UV region of electromagnetic spectrum, part of the Lyman series, of hydrogen has a wavelength of 9.12 times 10 to the minus 8 meters. Use the equation below, this one, to calculate the frequency of this line and hence its energy in joules. So what we got to do first to calculate the frequency. To find frequency, we rearrange the equation to C over lambda. We know C is 2.99 times 10 to the 8. We're given that in the question. And the lambda is 9.12 times 10 to the minus 8. Now you just put it in your calculator. Over 9.12 times 10 to to the minus 8, and that gives us 3.28 times 10 to the 15. Our next step is to find the energy, and energy is just HF. We know that H is 6.63 times 10 to the minus 54. We times it by the frequency we just found. And we put in a calculator again. And this gives us 2.17 times 10 to the minus 18 joules. The next part says there are 6.02 times 10 to the 23 hydrogen atoms in 1 mole. Use this info and your answer to part I to calculate energy in kilojoules, mole minus 1. So what you've got to do for this one, it says kilojoules, mole minus 1. We've got joules, so we've got to times our joules the number of hydrogen atoms in 1 mole. And this gives us 1308734.15 joules mole minus 1. Now we want this in kilojoules, so we divide by 1000, and this gives us 1309 rounded kilojoules mole minus 1. This I also show you in on my blog, so visit there if you need help. Next question is a big question. It's usually like a 6 marker on the exam. Describe the main features of the atomic emission spectrum of hydrogen in the visible region. Explain how these features arise and how their interpretation provides evidence for energy levels in the atom. So you basically have to explain what happens in the emission spectrum of hydrogen. So our first point is that in the emission spectrum of hydrogen, we have a series of lines, which we call energy levels. We also know is that these lines, you can draw it out to make yourself easier, and you might even get some points for that. We have a convergence limit. So the lines get closer together we also know that the energy between the ground and the energy levels, as the electron goes higher, the energy difference increases. That means, according to our equation, that frequency increases. We also know that the electrons rise by absorbing energy and after they fall back down, so if the atom is unstable, the electrons will drop back down they release energy or photon. This is how it's called, a photon. The energy that they release is called a photon. And is a certain amount of energy. We also can say that it's a Balmer series because it says the emission spectrum in the visible region. So we can show that you know that it's a Balmer series, because Balmer series is in the visible region. Lyman series is in the UV part of the spectrum, and Balmer is in the visible region. So we can write this. Yeah, I think that's enough. We've got 6 points. We explained the hydrogen emission spectrum. And yeah, I think that's all. So the next question is, describe the difference in absorption and emission spectrum. So what you know about absorption spectrum and what you know about emission spectrum. So in the absorption, the energy is absorbed by the atom. Electrons jump, and in absorption spectrum we have that spectrum that is all colored in, and the places where the electron absorbed the energy, we're gonna see black lines. And we also know that in the emission it's basically all the other way around. So the energy is emitted as electron falls down. And our spectrum is again the other way around. We've got a black spectrum, and the places where the energy is released by the electron will have colored lines. All of the lines are at certain wavelengths and certain frequencies, which are related to the energy. That's why these two equations are very important in this unit, because they show us how we relate both frequency, wavelength, and energy. So, as you can see, everyone makes mistakes, and even though I know this topic, I'm easy with confusing myself with rearranging the equation. So practice makes it perfect. Doesn't matter if you make a mistake, but if you know why you made that mistake and how you made that mistake, and you change it and make it right, that's what counts. So remember, everything I show you are my techniques and ways of learning and revising. If you have any questions about my videos, please comment or email me. I leave all the links in the description box below, I always do. Also, if you have any comments about the quality or content of my videos, please also leave them under this video. Thank you very much for watching. If you liked it, then leave a thumbs up, subscribe, and see you soon. Bye.